Okay, now we're going to continue our discussion on orbitals. Remember, as I introduced you to the idea of a periodic table, I said elements are somewhat grouped into certain groups called orbitals, and they have 4 letters: S, P, D, and F. Okay, every element will contain S. Some elements contain S and a P. Some elements contain S, P, and D. Some elements contain S, P, D, and F. But all elements, irrespective of where they are in the periodic table, all elements contain a S orbital. Okay. Now let's do some other soul search here to figure out how we're going to tie this idea back to the periodic table. Remember, I said in the concept map we started with the periodic table, went to the atom, from the atom we go to the orbitals, from the orbitals we go to the electronic configuration. Now we're in the orbital phase. Now let's get rid of this and bring it back. Okay. Now we did learn the idea of electrons. So for instance, okay, let's get this information for oxygen from the periodic table, and this is what it looks like. Okay, this means oxygen's got 8 protons, 8 electrons, and 8 neutrons. We just practiced this in our exercise. Now, how does this all assemble? We gotta assemble these. We can't just leave them like this saying, oh yeah, oxygen's got 8 protons, 8 electrons, 8 neutrons. Fantastic. How are they all going to go about arranging themselves in a plum and cherry model, or I think they call it plum cake and cherry model, I guess, because when you have a plum cake and you cut it right in the middle, you will see plums everywhere surrounding the core of the cake. So similarly, I'm going to go and get a different color. I'm going to draw just a schematic of it. Okay, we're not going to put any number of electrons, specific number of electrons, just understand it. Okay, this is the core of a single atom. Now keep in mind, a element has got so many atoms, and every atom has a structure which is then photocopied into the remainder of the other atoms. So this is the core, just like the Earth's core. This is the core of a atom, and then it's containing orbitals around it. Okay, how many are there will vary from one element to the other. I'm having really trouble drawing these circles. Okay, I wish there's a circle app on Wacom Bamboo. Unfortunately, there is none. All right, so that's a fantastic looking artwork right there. Okay, I'm going to give myself credit here because I was able to draw, you know, circles using my little pen here. Okay, so this is also known as the nucleus. Okay, nucleus, and these right here are known as orbitals. Okay, plural, orbitals. Okay, so every atom has a nucleus and a orbital or orbitals. You got to be careful. There's two elements in the periodic table that is a orbital, means there's only one of those available, but all other elements in the periodic table have plural orbitals, means they have at least more than one circle around the nucleus. Okay, so let me go back, okay, and refresh it. So every atom, okay, every atom has a nucleus and orbital, singular, or orbitals, plural. Okay, there's two elements you will see as I do this. There's two elements that only has a single orbital, whereas all other elements besides those two have orbitals, means plural. Okay, so let's go ahead and actually look at this slide that I created you. It's also available on Moodle. So I'm going to get through this. Okay, every element, as I said, it contains a nucleus and orbitals or orbital. Okay, and electrons, as I've already said, are negatively charged, protons are positively charged, neutrons have no charge. Now here's a little schematic. Remember, this is a single atom. We don't focus on the entire all 6.022 10 to the 23 atoms. We only focus on a single atom. Okay, and here is a better view. I think that's a better circle. Okay, and then if you see, that's just the cake, and then you got these orbitals and you got the nucleus, which is right in the middle. Okay, and then you've got electrons. If you follow the color pattern here, the black, which is the protons, and the red, which is the neutrons. This is not specific to a particular element or atom. This is just a generic version. Okay, so you've got your protons and neutrons are inside the nucleus, and if you see, the electrons occupy the orbital outside the nucleus. That's the take home message from this. Don't think there's always going to be 4 and 3 and then start counting this. This is not for any specific atom or element. This is specifically for a generic atom that I don't even think you can ever make an element out of this. I think they purposefully made it that way so students don't always relate it to this. Okay, so this is for a specific atom. As you see that, you will see a nucleus, and nucleus contains protons and electrons. The electrons are in the orbitals circling around the nucleus. Okay, so if we come back to our tablet version of it here, so if I have hydrogen, okay, if I have hydrogen, for which we determined there's 1 proton, 1 electron and 0 neutron. What does that mean? Okay, now we always draw our nucleus. This time, instead of just shading it black, I'm going to put 1p, means 1 proton is inside. There's no neutrons, but still neutrons go there. And then I'm going to take my time to draw my first orbital. Okay, okay, we have 1 electron, and that 1 electron goes here. Okay, all right, now this might lead to more confusion if I don't stop here and explain a few things. Okay, so we have only 1 electron, but the mere purpose of this is just to show you the representation of protons, electrons and neutrons on a larger scale. Now if you see that your protons and neutrons are inside the nucleus, which is this inner circle. Now I'm going to just slightly shade it so you can see it. So this right here is the nucleus, and this right here is my orbital, because there's only 1. I guess you can call it orbitals if you wish. And then this is the electron. Okay, as we continue our discussion and tie its relationship back to the concept map and the periodic table, we will start to generate complicated circles. It's not complicated if you understand it, but that's my job, is to help you understand it so it doesn't appear complicated. All right.